Welcome to FMA 0146 Basic Mathematics. In this video, we are going to discuss chapter 2.3 Absolute Value. In absolute value, we have two elements. One is absolute values equations. Another one is absolute inequalities. Okay, so we look at absolute values in the form of equations. Before that, we're going to give the definition of the absolute values. Okay, absolute value, or you can call it as the distance from the zero. Okay, so when you have the something called absolute 3, actually is the what is the distance from the origin. Okay, so because of this term we don't have the negative value, so although we go if we say that is the distance from 0 to 3 is 3 unit, and from 0 to -3, the distance also 3 unit. Okay, so that's why absolute value, there is no negative value, value. Okay, so by the definition, absolute x actually is equals to a positive value if your x greater than equals to 0. If you have a value less than 0, you will get negative x. Okay, so how we want to implement it into others function? So we doesn't care who is inside our absolute, as long as it is inside our absolute. So if we want to break this definition, so we will say that it will become a positive if your this x greater equals to 0. Okay, so whatever inside is greater than equals to 0, and it will become negative if the x plus 3 less than 0. But because we hardly write our inequality in this way, so our x is greater than -3, x is less than 3. Okay, so let's say if you have an x equals to -10, okay, how you want to know that is? Normally we just say that we substitute -10 plus 3 equals to absolute -7. So because absolute they say is a positive value, so this is what we normally do. But actually this one is incorrect in a certain way, but by the formal definition, for if you have x equals to 10, so means that it is less than -3. So we are going to substitute into this function. I have a -10 plus 3, so is -7, so it is 7. This is the main reason why we say absolute -7 is equals to positive 7. Okay, over here we have some of the properties of the absolute value. The first one, absolute is always greater than 0. So means that absolute A impossible is a negative value. Okay, and absolute A equals to -A. If you have an absolute A plus B, if you interchange B plus A or B minus A will give you the same answer, and for the multiply and divide are the same. Okay, now how we going to solve our absolute equation? First thing what we do is we are discussing one side with absolute, the other side is constant. Why? What is the special between the case 1 and case 2? The case 2 have the other side with a variable. The only difference is not the way to do it. The only difference is for the second case, we need to do the checking. For other cases, no need to do checking. As long as you have the absolute and the other side of the equation have an variable, you need to do the checking. Okay, now, so if I want to solve absolute x minus 3 equals to 6, how am I going to do? Okay, by the definition, we say that absolute x minus 3 equals to 6. So for this one, I can become positive. Okay, positive p and negative p. Okay, because the right hand side didn't change. But normally what people do is we didn't put the positive negative at the absolute, but we put on the other side, which is easier because okay, so means that if I shifted to here, it's the same. Okay, so but the thing is, this is the other ways to write the same thing. So if I want to break the absolute, what I do is my friend on the other side will get positive and negative. Okay, so x minus 3 equals to 6. So I shifted is x equals to 9. And this one I shifted, I get negative 3. Since I only have two answers, so I have a negative 3 and 9. So I put it into a curly bracket. Okay, the second questions, the second case also the same. That is, I have one absolute, but the thing is, the difference is the other side have one variable. So in this case, the way to do it are the same. When I want to break this absolute, one is a positive and another one with a negative, and then I rearrange everything, I get this answer. But as I said before, if you have a variable on the other side, what you need to do, you must do the checking. And how to do the checking? Substitute the value given here into the original questions. Then you check the left hand side, the value is it equals to the right hand side. And fortunately, this case both are valid. Okay, so how about we look at one case which is not valid. So when I want to break this absolute, one is a positive, another one is negative. And I solved this, so I got two answers. One, the candidate is 10 and the candidate is equals to 4. So when I substitute 10 into the original question, is 10 minus 1 is 9, and 20 minus 11 also 9, so this one is true. When I substitute 4 into the original question, 4 minus 1 is 3, but 4 times 2 is 8, minus 11 is minus 3, so this one is false. So this one is rejected, so I only have one answer, that is 10. Okay, so then we have the case 3, both sides with an absolute. Okay, so both sides in absolute. Why? If you see here, is just like the normal one variable. Sorry, one absolute. Actually, let us look at the general case. Absolute P equals to absolute Q. Okay, so when I want to break this one, the other friend will get one is positive, another one with negative. But okay, so this one I shifted my negative here, negative P, absolute Q. But we already said absolute is impossible to get a negative, so this one is rejected. Okay, so I have this one, P equals to absolute Q. So my P equals to Q, or my P equals to negative Q. Okay, so that's why I only have two cases. P is, sorry, this one is x minus P equals to positive and P equals to negative. Rearrange this one, you get two answers. And for both sides is an absolute, no need to do the checking. Okay, so how about if you have the one in absolute is a quadratic, nothing different. We are applying the same method. That is when we want to break the deal, one person get positive, another one get negative, and then rearrange everything. This is a quadratic. Use the calculator, give you the answer. And since this one is only constant, no need to do the checking. Okay, so let us look at this exercise. 2x minus 3 equals to 5. So only one absolute. So 2x minus 3 equals to 5, or 2x minus 3 equals to negative 5. So I can break the absolute. So this one I shifted. 2x equals to 8, x equals to 4, and 2x equals to negative 2. X equals to negative 1, and actually you can leave your answer in this way, or you can combine them back into this one. And remember, over here is a curly bracket. Okay, and then how about the second question? Remember, when we want to solve, we want to use the definition to break the absolute, it must stand alone. So we send our 9 to the other side. So absolute 7x minus 3 equals to 5 minus 9. This one is negative 4. But from the beginning, we already said absolute is impossible have a negative. So that means no solution. Okay. Now, next, how about this one? When we want to break anything for the absolute, we need to let it stand alone. So I have an absolute 6 minus 2x equals to 24 minus 8. This one shifted here, become minus 8 and divided by 4. Actually, this is a 16 divided by 4. So I have an absolute 6x equals to 4. Then when I want to break this one, 6 minus 2x equals to 4. Or 6 minus 2x equals to negative 4. And then this one is 2x equals to 2, x equals to 1, and 2x equals to 10, x equals to 5. And since there is no x and on the other side, so we no need to do the checking. How about this one? Nothing different. So first thing, I have an x squared plus 1 equals to 5, x squared plus 1 equals to negative 5. This one is x squared equals to 4. So x will be having plus minus 2. Okay, so still remember, this one actually is x squared equals to x equals to plus minus square root of 4. That's why it's 2. Why there is a plus minus? Remember, 2 square and negative 2 square, they are giving you 4. Okay, how about this one is x squared equals to minus 6, and this one is impossible because this one will produce complex number. So this is rejected because you only deal with the real number. Okay, is it any different for this one? Although the right hand side seems okay, on the right hand side seems complicated. The way to break the GL are always the same. X plus 3, x squared minus 4x minus 3, or x plus 3 equals to negative x squared minus 4x minus 3. So this one I shifted here. So x squared minus 5x. This one shifted here, minus 6 equals to 0. So x minus 6, x plus 1. So equals to 0. So my answer is x equals to 6 or x equals to negative 1. And then my right hand side, negative x squared plus 4x plus 3, x plus 3. So this one cancel. I have my negative x squared. Okay, sorry, I make it to become positive x squared minus 3x equals to 0. So x minus 3 equals to 0. So my x actually is 0 or x equals to 3. Okay, so now I have a 4 answer. And as I said, if your one side is absolute, the other side consists of a variable, you must do the checking. Okay, so how we going to do the checking? We substitute back into the original. Okay, so when x equals to negative 1, so absolute negative 1 plus 3 equals to negative 1 square minus 4 minus 1 minus 3. The left hand side is true, the right hand side also true, so this one is true. So this one is accepted. Okay, so you need to try for x equals to 6. Okay, after that, how I tried the x equals to 0. When x equals to 0, 0 plus 3, and then equals to 0 minus 3. So 3 is not equals to negative 3, rejected. And you need to do for x equals to 3. Okay, so if the right hand side have the variable, you must do the checking. Okay, so if both sides have absolute, so nothing different like 1. So we have 3x plus 2 equals to x minus 6, and 3x plus 2 equals to negative x minus 6. Or maybe you said that you can use negative 3x plus 2 equals to x minus 6. As long as we choose one side come with the minus is fine enough. Okay, okay, so this one I will have 2x equals to negative 8. x equals to negative 4. And then how about this one? So I use the second one, negative 3x minus 2 equals to x minus 6. So I shifted 4x equals to 4. Am I correct? Okay, shifted here is 4x. This one is 4. So my x equals to 1. And this one, no need to do the checking because both sides are absolute. Okay, now we move to absolute inequality. In the absolute inequality, we have extra two definitions. It's lesser than and greater than. Okay, you need to pay attention to. We are looking at the less than or greater than because of the absolute. Okay, it's not simply you look at the questions with a lesser than you use this definition, it's greater you look this definition. No, it depends on whether it's an absolute x less than or absolute x greater than. Okay, for this absolute less than, if the definition is the distance between x and the origin is less than 3. Okay, so for this one we can rewrite as an x is in between 3 and negative 3. Okay, so this is the 2 and you have no choice. You have to memorize that. Okay, and over here, please be careful with the terms and or. Why? This is an or. And this one, when you want to break, it will become an and because they are come from the one family. Okay, so let's look at the first example. I have the absolute on my left hand side and the sign here is greater, so I am going to use the second definition because the absolute is greater than. Okay, so what I do, I follow this one, x greater than p, so I have 2x minus 1 greater than my p. Okay, and then rearrange it's greater than 3 and this is an or. Okay, so the second one is my 2x minus 1 less than minus. Rearrange this one, so you can put it this way or you can leave your answer here. The second one, if you see that the absolute is here and this one is absolute less than equals to, doesn't matter. When you have the equal, so you just using the same formula but you put an equal there. Since this is a lesser than, so we have the 7 minus 3x in between the negative and the positive, and because of 3 part having the x, so we need to separate them. Okay, so the first one we separated them. The first pair is the 1 and 2, and then the second one is the second and the third. Okay, we rearrange everything. Okay, then you get this one. And one thing that is, if we see why they arrange back into this one, because this is an and. Okay, and normally x is in the middle. This one lesser than, this one greater than. Okay, there is no much combination here. We just combine to answer. Example 3. Okay, so if you have this one quadratic less than 4, doesn't matter, we still absolute is less than, so we are separated into negative 4 and positive 4, and because quadratic, we always need to separate them into 2, the first and second and the second and the third. Okay, so when you separated them, this one is already become your chapter 2.2 inequality for the quadratic. So this one shifted, x squared plus 2x. You need to find where is your root. Your root is 0 and negative 2. Above the x-axis is positive, below is negative, and this one is greater than, okay, this is greater than 0, so that's why we take positive. Okay, on the other side, this one is x less than 0, so that's why we take the negative, and unfortunately they are from the same family before. We need to combine them together. And then we have how many? 0, negative 2, negative 4 and 2. So we have 4 different value here. We arrange according increasing order. Okay, so from the right hand side is negative 4 to 2, so negative 4 to 2, and the one below is less than negative 2, greater than 2. So this one are the intercept. So that's why you have the answer for negative 4 until negative 2, 0 and 2. And then let us look at some of the exercise. First thing, this is absolute, greater than, so we use this one. So x plus 4 greater than 4, or x plus 4 less than negative 4. Okay, so x greater than 0, x less than negative 8. You can keep your answer in this way, or you can change it to like the one above. Then the next one, as I said, if we want to break the absolute, we must keep absolute on one side. These two are very irritating. We need to send it to the other side. Or for me, that is, I just shifted this one to the other side. This one come back. 9 minus 3 greater than 2 for x plus 1. I don't want these two. I send it here. 9 minus 3. Okay, it's a 6. 6 divided by 2 greater than absolute for x plus 1. And I want to exactly look like this. That's why I use 4x plus 1 less than 3. Okay, this one is a less than. That's why I said we follow the absolute. It's a less than. So I have 4x plus 1 less than 3. And in between negative 3 and 3. So I shifted 4x. Shifted, this one is 2. This is negative 4. So x is between negative 1 and 1 over 2. Okay. Next, we look at this one. Any different with the previous? No. So we shifted 3 minus 1 less than absolute 2 minus x. Okay, this one is a greater than. Okay, how I know? Okay, I rearrange 2 minus x greater than 2. Okay, then I break this one. 2 minus x greater than 2. Or 2 minus x less than negative 2. I shifted. So x is less than 0. And x is greater than 4. So that's why you have this answer. Okay, next one. Okay, when you have an absolute is bounded by 2%, you have no choice. You only can do it separately. The first one, 2 less than x minus 1. And, okay, because they are from the same family, that's why it's an and. X minus 1 less than equals to 5. Okay, so when you want to break this one, it's a greater than. Okay, so from here, I show it to you. It's a greater than. So x minus 1 greater than 2. Or x less than, x minus 1 less than negative 2. I arrange back x greater than 3. Or x less than negative 1. Okay, so this is the answer from the left hand side. And then I have an and. Okay, this one is lesser than x minus 1, 5, and negative 5. So x is less than 6 and negative 4. So I have two different set of answer. As I said, we see how many friends we have. The smallest is negative 4. Second is negative 1, then 3 and 6. From the left hand side, my answer is this one. Okay. And from the right hand side, I get is negative 4 and 6. Why one is the one with a circle, another one is a dot? Because this one is not inclusive, this is inclusive. The intercept is only these two part. So you have a negative 4, okay, inclusive and exclusive. Why this one is 0? So that's why you have a negative 1 and union. Okay, 3 and 6. Okay, sorry, so this one is a 3. Okay, so settle. Next, okay, so this one nothing much, same thing, we shifted. Okay, I want to make it look simpler. X minus 1 less than equals to, because the sharp point is pointing at my absolute, so that's why it is this shape. I have a negative x squared okay, plus 2x. This one shifted to the other side is plus 1. After that, because this one is lesser than, so I can break it into x minus 1 in between negative x squared plus 2x plus 1 and negative x squared plus 2x plus 1. Since I have 3 components and 3 components consist of x, so I need to separate them. X squared minus 2x minus 1 less than equals to x minus 1, and x minus 1 less than equals to minus x squared plus 2x plus 1. This one I rearrange. X squared minus 3x. This one shifted here, it becomes 0. So my x minus 3 less than 0. Smiling face. 0, 3. Positive, positive, negative. Since this is a lesser than, so I take my answer for the negative, 0 and 3. And my right hand side doing the same thing. Okay, I don't like negative, so I have an x squared. I shifted here, so I become minus x. This one shifted here, minus 2, greater and equals to, shifted, okay, less than 0. Okay, minus 2, less than equals to 0. Okay, so after that, what we do is, this one is x minus 2, x plus 1. Equals less than 0, smiling face, negative 1, 2, and positive, negative, positive. This one is negative. And since this one is less than, so we take the negative sign. So it's in between negative 1, x, and 2. Okay. Now we combine both answer. We have the smallest negative 1, 0, 2, and 3, 0 and 3, negative 1 and 2. Intercepting is only here, so it's between 0 and 2 only. Next, how about this one? Okay, the one irritating, we send it send it to one side. So x squared minus x less than equals to, this one shifted here, 3x plus 1. When I want to use this definition, 3 also is not allowed. So I shifted here, x squared minus x divided by 3, absolute x plus 1. And then when I want to break this one, actually is greater than. So x plus 1 is greater and equals to x squared minus x divided by 3. Or x minus 1 is greater and equals to minus x squared minus x divided by 3. Okay, after that, 3x plus 3 greater x squared minus x. So I have an x squared. Shifted here is minus 4x. This one shifted here is minus 3 less than 0. And then this one is become 3x plus 3 minus x squared plus x. I shifted here, x squared. This one shifted here is plus 2x plus 3 greater than 0. And then find the value. Then if you see maybe some of the value is not valid, so you need to do the checking. And then over here, there are some questions that I'm going to discuss in another video. So thank you.